Hello everyone, welcome to day 11. Next question is Cadence algorithm maximum subarray sum. Do it on lead code. The question is given an integer array. Find the subarray with the largest sum and return its sum. The array can contain positive and negatives both. Obviously, because if it contains all the positive numbers, then it will be the whole array for having the maximum sum. So I'm aware of this question. I have done this cadence algorithm before a couple of years back. I don't know if I remember exactly. We'll try to solve it. So the brute force approach would be that we find all the possible subarrays in this array. For doing so, we'll iterate over the subarray. Like for example, if this is the array, then in first iteration we'll have first subarray is -2, then we'll have -2 and 1, then next subarray will be -2, -1 and 3, and so on. We'll keep adding the numbers. Then next subarray will start from this index, so 1, next will be 1 and -3, next will be 1 -3 4, and so on. So like this we'll have all the subarrays. The code will be like, we'll start iterating from the first index. So this I will represent the starting index of the subarray, and j will represent the end index of the subarray. So j will start from I to j will be basically for iterating over the subarray. J will start from I to again n, j plus plus. Will find the sum, and here initially sum will be 0. Now sum will be sum plus nums j, and we'll keep a max sum, and at each iteration we can check if max sum if basically max sum will be max of both, max sum and sum, and at the end we can return the max sum. So like this we'll find the sum of all possible subarrays and return the result. This is one optimal solution. This is the brute force approach. The time complexity will be n square in this case. Next, coming to the optimal solution, for this we have the cadence algorithm. So what we do is, the intuition is that I think whenever we find an element, we check that if it is beneficial to keep it in the subarray or not. Like for example, initially let's say the max sum is 0, right? Initially the max sum is 0. Now when we are at first index, we have -2. We'll check if -2 will add current sum. We will initially current sum will be 0. We'll add -2 to the current sum, so current sum will become -2. Now what we see that on adding -2 to the current sum, is it and then we'll move forward. Okay, we are now at 1, so we'll check max sum is also -2, or max sum is 0, because let's take max sum as int min max, int min I mean, because we want to iterate it. Maximum sum can be a lowest amount, less than 0, so let's keep it int min. Then we'll check that if at first iteration we'll check if this current sum is greater than max sum. Yes, it is, so we will make max sum as -2, and we'll move forward to the next index. Now we will add 1 to the current sum, so current sum will become -1. One second, one more thing. At this index only, we'll check. At this index only, when we have current sum as -2, we will check, is it beneficial to move forward with this -2, keeping this -2 in the sub array? No, because when we are moving forward, be it any number after -2, be it positive, negative, or 0, if we are adding -2 to it, then the next number will decrease only, it will not increase, so we will not have the maximum value. So that's why we can drop this number and keep it 0. Now next, at next iteration, we have 1. So current sum, if on adding 1 to the current sum, it is increasing, it is positive, so current sum will become 1, and max sum will also become 1, because this is greater than current max sum, so max sum will also become 1. Now at next iteration, when we will add -3 to it, what will happen? When we will add -3, then max sum, current sum will become -2, current sum will become -2, and we will not update max sum because this is greater than -2. Now we'll move forward at 4. Now here we will again check, is it beneficial to move forward with -2? No, because as it is a negative number, it will decrease -4, so we will mark it as 0 and move forward. Now next iteration, current sum will become 4 and max will become 4. Max will also is greater than this, so max sum will also become 4. Max sum is also 4. Now at next iteration, we have -1. We'll add -1 to current sum and it will become 3. And now we will not make it 0, because it is possible that moving forward we have a pause after these. When we have these two in sub array, the sum is becoming 3, so it is possible that there is a bigger number after this, and on adding that it becomes much bigger, because it is still positive, so we will keep it. Max will still remain 4, because max is not, it is greater than 3, but current sum will be 3, and max will remain as 4. Now at next iteration, we have 2. When we add 2, see, now current will become 5, current will become 5, and max will become 5, right? And we will take it forward, and then we have -5. On adding -5, it will become 0, right? It will become 0, current sum will become 0, we'll still keep it, and max sum will also remain 5, and then at next iteration we have 4. Now on adding 4, current will become 4 and max will remain 5. So by this, okay, I missed to add this one, 4 2, I missed this one, but yeah, 4, then I added -1, then I added 2. Okay, after I was supposed to add 1, but I added this, fine. But in this example, if 1 is not there, then in such case the result will be 5, and that is Cadence algorithm. So I'll quickly write it out. We'll take a current sum as 0 and int max as integer dot max min, integer dot min, is it integer dot min to find the minimum value in Java? Min value, I think it is min value, huh? Okay, integer dot min value, and we'll iterate over int I equals to 0, I is less than nums dot length I plus plus, and then at each iteration we will add current value, add current sum equals to nums I plus current sum, and if max is less than current sum, then max equals to current sum, and if current sum is less than 0, then current sum is 0, we'll drop it, and at the end we can return the max value. And in this case the time complexity is order of n and space complexity is order of 1. What else? We have nums size of array cannot be 0, so this should work. Great, we'll mark it as done. Next question is, cadence algorithm maximum subarray given a integer array. Now find the subarray with largest, return the sum of elements present in that sub. Isn't it the same question? It is the same question, right? The subarray 0 to 4 index. Brute force, what is it? Optimal iterate through the array using index I during each, add the current element and running sum, keep track of maximum. If any point sum becomes negative, reset it to 0, continue. It's the same thing. Then what? Follow up. Can you print the subarray that has the max? Okay, they want to print the subarray which is having the maximum sum. Then we'll have to keep track of the start and end of the maximum subarray indexes. I think it's quite possible. We'll keep track of both the starting and end of the subarray. Fine. Next question is, waste time to buy and sell the stocks. You are given an array price where price I is the price of given stock on ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell the stock. Return the maximum profit you can achieve. If you cannot achieve any profit, return 0. Okay. So what we want to do, we want a value, we want to buy on some day and then sell on a later day. So this value, the later value should be greater than the present value, the first value. Basically we want to find two integers in this array in such a way that the difference of them should be maximum, and the difference should be maximum, and the smaller value should be at the start and bigger value should be at the end. Okay, so the brute force approach for this would be that we find all possible pairs in this array. Like for example, first pair is 7 1, second pair is 7 5, then we have 7 3, then we, and so on. And then we'll start from 1 5, then we have 1 3, then we have 1 6, and at last 1 4. After this we'll have 5 3, and we'll have 5 6 and 5 4, and at this point we have 3 6 and 3 4, and at the end we'll have 6 4. I don't know why I did it. I wrote down all the pairs. I'll just do this one also because now it is giving me anxiety. Only one line is left. 7 4, sorry 7 कौन सा हो गया, 7 3 हो गया, 7 6 and then 7 4. ठीक है. So these are all the pairs, and then हम सारे pairs का difference find out कर लेंगे, और जो मैक्सिमम डिफरेंस होगा वो हमारा आंसर हो जाएगा. और इन पेयर्स को फाइंड आउट करने के लिए हम दो फॉर लूप लिखेंगे. सो फॉर इंट आई इक्वल्स टू 0, आई इज़ लेस देन एन, आई प्लस प्लस, एंड देन this will give us the starting, and then for int j equals to j equals to i plus 1 से स्टार्ट करेंगे ना, बिकॉज अगर हम यहाँ पे हैं तो सेकेंड इंडेक्स इसके बाद वाला होगा, ये खुद को तो नहीं काउंट करेगा. सो j equals to i plus 1, j is less than n and j plus plus. ऑल्सो आई जो होगा वो 7 से लेके सिर्फ 6 तक चल रहा है ना आई, तो स्टार्टिंग वाला इंडेक्स है वो 7 1 5 3 और 6 हो सकता है, 4 नहीं हो सकता, क्योंकि अगर हम when we are already at 4 then we cannot sell it if we buy it at 4. इसके बाद कोई नंबर ही नहीं है. then that means I will run from 0 to n minus 1, and then we'll find the difference. We'll keep a max. Initially max 0 होगा, and we'll check if nums j minus nums I is greater than max, तो हम max को अपडेट कर देंगे. max equals to nums j minus nums I. That's it, and then we'll return max. So this is the brute force approach. In this case the time complexity is order of n square, and space complexity is order of 1, remains same. Now coming to the optimal solution for this. In optimal solution what we do is, let's say we buy at this price 7. Okay, now we'll start iterating over this array and we find 1, right? Now we want the buy price to be minimum, right? So when we have bought at 7, then if we sell at 7 then it will be profit will be 0, which in any case it's 0 if there is no answer. Then when we are at 1, so the minimum buy price should be now 1 because it is less than 7. Initially buy, let's say min buy price initially was 7. Now when we are at 1, then now min buy price is 1, and profit is still 0 because if we buy at 7 and sell at 1, then it is you want maximum a single day, buy and choose a different to sell the stock, return maximum profit achieved from this transaction. If you cannot achieve any profit तो पॉजिटिव ही होता है ना. सो अगर हमारे दो ही नंबर्स है 7 and 1 तो 0 आएगा आंसर, बिकॉज इफ वी बाई एट 7 and सेल एट 1 तो -6 हो जाएगा, विच इज़ नॉट द आंसर. सो इन दिस केस विल चेक कि मिन बाई तो 1 हो सकता है, बट हमारा प्रॉफिट प्रॉफिट इनिशियली ज़ीरो था और अभी भी ज़ीरो ही रहेगा, प्रॉफिट इज़ ज़ीरो, बिकॉज दोनों को माइनस करने पे मिन बाय में से हम 1 माइनस करेंगे तो ज़ीरो आएगा. नाउ वी आर एट 5. ठीक है, अब मिनिमम पे बाय करके 1 पे बाय करके अगर 5 पे बेच रहे हैं तो प्रॉफिट हमारा 4 बन जा रहा है. एंड शेल वी अपडेट मिन बाय? नो, बिकॉज अब अगर हमने 1 पे बाय किया है, इसके बाद हम कभी भी बेचें, ठीक है, पर हमें 5 पे बाय नहीं करना, बिकॉज हमारा प्रॉफिट हमेशा, वी विल ऑलवेज हैव अ स्मॉलर प्रॉफिट इफ़ वी वांट टू बाय एट एनी ऑफ दीज 2 numbers or any of these 3 numbers. When we should buy? We will buy at 1 if we want to sell at any number after 5, because then only we will have a maximum profit. तो min buy will remain as 1 और प्रॉफिट हमारा 4 हो गया. नाउ वी आर एट 3. now when we are at 3, min by, shall we update min by? No. and profit shall we update? because profit 4 है, अब profit क्या होगा? min by minus 3, profit 2, which is not maximum, so we will keep it as it is. Next is 6. we shouldn't update min by, and shall we update profit? yes, because when we buy at 1 and sell at 6, profit will be 5, and similarly 4 पे कुछ नहीं करना, तो profit, max profit will be 5. I think they should work. Let's write it out quickly. So we'll have 2 variables, min by, minimum buy initially हम कर लेते हैं prices 0 पे, एंड इंट min प्रॉफिट हमारा प्रॉफिट हमारा जो होगा मैक्स प्रॉफिट कर लेते हैं इसको, और लेट्स कॉल इट प्रॉफिट हमारा इनिशियली 0 है. नाउ फॉर इंट आई इक्वल्स टू 1 से स्टार्ट कर सकते हैं. वी कैन स्टार्ट फ्रॉम 1 बिकॉज 0 पे देर इज़ नथिंग. आई इज़ लेस देन एन, आई प्लस प्लस, एन इज प्राइसेस डॉट लेंथ, prices dot length. Now at each iteration we can check if this number, initially we can check if this number prices I minus min by is greater than profit, then profit equals to prices की स्पेलिंग है PRICES, prices I minus min by, right? now also we will check if min by is greater than prices I, then min by equals to prices I, and at the end we can return the profit. I'll quickly dry run this solution. I'll take this, I'll take this only. So what will happen is, initially, wait, I removed the constants, is it? Return profit. So initially this is the array. Now in this case min by will be 7 and profit will be 0. Now next I is 1. We are checking price I minus price I, which is 1 minus min by is 7. 1 minus 7 is greater than profit? No, it is not, so we will not do anything. And then we are checking if min by is greater than prices I. Is 7 greater than 1? Yes, it is greater, so min by will be 1. So here min by will become 1 and profit will remain 0. Next I is 2. We are checking 5 minus 1 is greater than profit. Yes, it is greater than profit. So in this case, profit will become 5 minus 1, 4. Also, we will check if min by is 1. Is it greater than 5? No, it is not. So min by will remain 1. Next, I is 3. I is 3, profit, I is 3, so this is, we are at 3. 3 minus min by 3 minus 1, 2. 2 is greater than profit? No. So profit will remain same. And if min by 3 is min by 1 is greater than 3? No. So this will also remain same. Nothing changes in this case. Wait a second, but this is correct. Now we have I is 4. Now we will check I is 4, so we are at 6. Now we'll check if 6 minus 1, 5 is greater than profit. Yes, it is greater, and so profit will update, profit will become 5. And if min by, which is 1, is greater than 6, no, it is not, so min by will remain same. And finally, when I is 5, then 4 minus 1, 3 is greater than 5. No, it is not, nothing will change. And then min by is 1. Is 1 greater than this value 4? 1 is greater than 4? No, so min by will also remain same. So at the end, this is the result, and then we'll return profit. So profit is 5 at the end. Cool. We'll run this code. Bracket is missing. Oh, there is an extra bracket here. Cool. And in this case, the time complexity is order of n, space complexity is order of 1. There is one more better solution I can see. Let's see the solutions. It is same thing. Fine. Next is rearrange array elements by sign. You are given a zero indexed integer array nums of even length consists of an equal number of positive and negative integers. You should return the array of nums each such that the array follows given condition. Every consecutive pair of integers have opposite sign. Matlab every consecutive pair of integer, acha, okay, side by side we need positive negative like this. For all integers with same sign, the order in which they were present in nums is preserved. The rearranged array being with the positive integer, begins with a positive integer. Okay, so basically the order should remain same, like we want 3, then minus 2, then 1, then minus 5, then 2, then minus 4, like this. Okay, so this is the array. The brute force approach for this would be that we take 2 more arrays of size n by 2. We'll take a positive array, and we'll take a negative array, and we'll store all the elements. We'll iterate over this, store all the positive elements like 3, 1, 2, that's it. And in this we will store all the negative elements, minus 2, minus 5, and minus 4. Then we'll start iterating over both the arrays, and we'll start filling this array. So for example, what we'll do is for int I equals to 0, I is less than size of this positive one, positive array dot length I plus plus, and in nums I will fill nums I, nums let's say j plus plus equals to positive I and nums j plus plus. Basically for simplicity we'll do this and then j plus plus, and then again for nums j equals to negative I, and then again j plus plus, and initialize j to 0. So what is happening is at 0th index will have a positive, then at j will become 1, then first index will have a negative, j will become 2, then at second index will have the next positive, then negative, then positive, then negative, and like this will have this filled. In this case time complexity is order of n by 2 with order of n, because initially we are iterating, so order of n, although n by 2 is also n, so order of n, and space complexity is order of n as well, which I think is not required, which is not optimal solution. Probably we need to find a solution with order of 1 space complexity. So this is one way of doing this. We want positive, then negative, then positive, then negative, like this. And both positive and negatives are of equal numbers. I'm getting an idea, I'm thinking out loud. So what if first of all what we do is we set all the positive numbers on the left side and all the negative numbers on the right side, and then we will do this merging. So like this, initially what we'll do is we'll make this array like 3 1 2, and then -2 -5. How we'll do it this I don't know right now, but I'm just thinking out loud. So we will do this, we'll make a separation, positive numbers at the beginning, negative at the end, and later on then we'll iterate over this array and then make it like 3 -2. 1 will go here, 2 will go here, नहीं 3 1 यहाँ पे जाएगा ना, तो 3, how we will mix it then? 3 के बाद we need -5, sorry 3 के बाद we need -2. What if there are more numbers like 7, यहाँ पे -2 -11, make it 1 2, for simplicity 3 4, and these are 1 5 6 7 8. So we need 1, next we need -5, and then we need 2. 1 minus 5. Okay, they're saying it is not required to do the modifications in place. Then what's the problem? If it's not required to do the modifications in place, then we can use a new array, na? Modify after rearranging the elements to satisfy the. If we have to use a separate array, then what's the issue? The earlier solution was good enough. But is it not possible to do it without using extra space? It's not required to modify in place. But if we are using extra space, then why is it a medium question? If it would have been an easy question, then I would have agreed कि we can use extra space. But if it's a medium question, then there is some trick to it. I'm thinking like this is easier to do, I think, because we'll take 2 pointers, one at the start, one at the end. We'll start iterating. We'll start iterating. Whenever we see a negative number from the end, we'll swap it. Or we just take one pointer. Okay. We'll start iterating. Whenever we see a positive number, we'll keep track of it. And then whenever we see a negative number, we swap it. Let's see the hint. Divide the array into one comparing only positive, other only negative. That is what I'm doing. Merge the 2 parts to get a result. This is the answer for this. Is there a trick in merging them? Let me try to write the code, which I was thinking before. So let's take one array called int positive, and a nums is of positive length is even, na? So int n equals to nums dot length new int of size n by 2. Int, let's keep it short, negative equals to new int n by 2. And we'll iterate over this array. Int I equals to 0, I is less than nums, I is less than n, we can do I plus plus. We'll put the values. If 0 हो सकता है क्या? This can be 0. अच्छा, it is greater than 0, 1. So if nums I is less than 0, then negative we'll have to iterate this also, na? So let's take int positive index equals to 0, int negative index equals to 0. So we'll take negative index plus plus equals to num psi. Else we'll do positive में positive index plus equals to num psi. Now we have separated them. Now we need to merge them. So what we can do, again we will mark these as let's say int index equals to 0. For int I equals to 0, I is less than n by 2, I plus plus, and then nums index plus plus equals to positive I, then nums index plus plus equals to negative I. That's it. Return the same array nums. Done. But why was it a medium question? Let's see. Are they doing it in place? No, right? They are taking a separate array. Initialize to pointer track even and odd, positive and negative. Placing the positive at the desired. Okay, so they are creating, instead of creating it like this, they are creating one more array and putting the elements directly into them and then returning that can also be done. That is also a good solution. Let's see more. Do you know? The follow-up question. He's doing same, positive का अलग से array, negative का different array, and then merging. Are you good with the? Let's discuss time and space. Space complexity is order of n, time would be order of n. Once filling in positive, cool, then write the code. Tap tap written the code. To here you have used 2 iterations. Can you do it in 1 iteration? Okay, let me think. What about space? Space can be order of n. If you can optimize space, we are good. Okay, I think since we need to preserve order, it would not be possible to do it in place, so I will use one array size n. Since I know the elements is even, its position would be 0 first time and next time plus 2, and directly putting it in the array. That is what they are doing. We have some time left. I have one follow-up question on this. What if the order doesn't matter? Can you do it in place? Yeah, if order doesn't matter, then I think we can do it in place. So let's say, if I'm not looking at the solution right now, let's say this is the array and they are saying that order doesn't matter. Then what we can do is we keep track of positive and negative. So int positive and int negative. Two pointers, positive and negative. And at each iteration we increment it by +2, not +1, we increment it by +2 if the value is filled. So let's say we'll start iterating over the array in I equals to 0, I is less than n, I plus plus, and we will check if positive is even, no, not like this, let me think more. So this, the earlier solution I was saying. So we can move all the positive numbers at the beginning, 2, and then -2, -2, -5 and -4, and then we'll swap the even index elements with the negative ones. So this is here, we'll swap it with this one. Oh sorry, this is here, we'll swap it with this one. So it will become 3 -2, then 2, then 2, then then 1. So we need to swap it with this one. So -5, -5, 2, -2, -2, 1 and -4, like this. So we'll swap the even indexes of both positive and negative. That should work. And in order to move all the negatives, all the positives at the start and all the negatives and at the end, what we can do is we'll keep track of positive. We'll start iterating over this array, and whenever we find a negative, we'll keep track of it. Initially it will be -1, or initially let's say it's 0. Whenever we find a positive, we'll swap it with this, or let's take a negative. Initially it is 0. Will not update negative until we find a negative value. So we'll keep iterating. We find a negative. If we find a negative index will be -2. Again we find a negative, we will not do anything. Then we find a positive, so we will swap this value with the negative index. So negative will become, and we will increment negative. So negative will become negative will become negative was the index 0, 1, 2, negative was the index, negative will become 3, and we will swap 2 with -2. So this will become 2 and this will become -2. Like this we will segregate all the positives and negative, and later on we will merge them. Okay, let me think. What about space? This is done. Sometimes, okay, let me think. As we know, the order doesn't matter. Also we have equal numbers, so what if the positive is not in correct index? We can get negative and swap them. Same negative, if it is not at correct, we can get the positive and swap them. Step 1, in same iteration also we can do. Okay, so like this. So whenever we have a positive, okay, we'll start iterating, and we'll uh, we'll see on only on the positive indexes we want the negative, right? At the odd indexes we want the negative. So we check the first odd index, it's positive, so we'll keep track of it. Next we'll go to this, it is negative. uh, no, we will go on the positive indexes and we'll check. Whenever we find a negative, we will swap it. So this will become -2, and then we'll go to next -2. This is correct, I think. Yeah, this should work. This is cool. Let's mark it as done. I'm good for today. We'll close this.